All right, algebra kids, this is the last video, 4 out of 4, and it's on direct variation. So I will go through the direct variation notes and some problems, and then I will summarize and finish up some administrative things before you are set to finish up and prepare for your test next week. Okay, so direct variation, what is it? It is a proportional relationship. Okay, now key features. Okay, the line goes through the origin, so it goes through 0, 0, and there is no y-intercept. Let me put this in bold. No, there's no y-intercept. Okay, and one additional thing is that this is a special case for rate of change, which is essentially the same thing as your slope. Now, for direct variation, the equation is y equals kx. And here, k is the constant of proportionality, or you may see constant of variation. Okay, so these are all the notes you need to fill in. Proportional relationship goes through the origin, no y-intercept, and is a special case for the rate of change, aka slope. K is the constant proportionality or the constant variation. The equation is y equals kx. So you have the option of pausing here and finishing up the notes. If not, let's continue. Okay, so indirect variation. The ratio between the variables stays constant or the same. Okay, so let's look at a couple examples. In the following problem, does the ratio between, and I don't want to write movies you buy online and account balance over and over again, so I'm just going to label these x and y. So does the ratio between x and y remain constant? Let's see. And remember, ratio, we're doing change in y over change in x, or rise over run, or y over x. So the ratio we are looking at is y over x. So let's see, x, the increments are by 1. The increments for y are negative 1.5. So the difference between my y's is negative 1.5, it's constant. The difference between my x's is 1, that's constant. So y over x gives me negative 1.5 over 1. And so k, the constant proportionality, is negative 1.5, which means that my equation is y is negative 1.5x. And if you plug in 0 for x, you get 0. Plug in 1 for x, you get negative 1.5. Plug in 2 for x, you get negative 3. 3 for x, negative 4.5. 4 for x, negative 6. You can pause here and copy down what you need to. Otherwise, I'm moving on. Okay, excuse me. Question 2, does the table represent direct variation? There's a difference of 2, difference of 2, difference of 2. Okay, so the x's work. Difference of 8, difference of 8, difference of 7. So ratio 8/2 works, 8/2 works, 7/2 does not work. This is not direct variation because the ratio does not stay constant. Okay, you can pause here. If not, let's move on. The time it takes to hear thunder varies directly with the distance from the lightning bolt. Determine whether the data set shows direct variation. If so, write an equation that describes the relationship. So again, looking at the intervals, we have 1, 3, 2, 0.2, 0.6, 0.4. We have different increments for x and y, but we don't care. We care about the ratio of y over x. So our first ratio is 0.2/1. Our second ratio is 0.6/3. Our third ratio is 0.4/2. We can simplify these two. So this simplifies to 0.2/1. This simplifies to 0.2/1, which shows that it is a constant rate of change, as well as we have a constant of variation or a constant of proportionality, which is our k. So 0.2/1, that is k. So this is direct variation. So even though there was a difference in the increments, we care about the ratio between the increments. Okay. Moving on to number 4. The cost of buying bags of apples for the harvest festival varies directly with the number of bags purchased. What will be the cost of purchasing 7 bags? Well, if you look, 1 bag is $5. So if we're looking at y equals kx, we know x is 1, we know y is 5. What does k have to be to give us 5? K has to be 5. So our constant proportionality is 5, which means our equation is y equals 5x. That is our equation. So if we want to find the cost of purchasing 7 bags, we do y equals 5 times 7, and that gives us 35. So the cost of purchasing 7 bags is $35. So you can pause here if you need to. Otherwise, let's move on. Okay, 5 and 6 are pretty straightforward. Do the following equations show a direct variation? If so, what is the constant variation? A is a yes, B is a no, C is a yes, 4 and 2/3. I went through that really quickly, but I want you to just take a moment and think about whether I'm correct or not. And if this is indeed wrong, how would I fix it to be direct variation? And then what would be the constant of variation or the constant of proportionality? So I will give you a moment to think about that. Okay, as you are thinking. Okay, remember, direct variation goes through the origin. It's a proportional relationship. There is no y-intercept. Okay, number 6, which do the following graphs show a direct variation? I can tell you right now, A does not, B does, C does not. I'll let you take a moment and figure out whether I'm correct or not. Okay, so you can pause here and you can write down your thoughts, but I'm going to go ahead and move the screen up so I can do number 7. Okay, number 7, if x and y vary directly, find the missing value. Okay, so some steps to consider. If you're ever asked to find a missing value, whether it be x or y, and they give you 2 points, or they give you So before I even start, you may also see if y is 15 when x is 3, then what is y when x is 12? This is another way that they may word it in a question, on a test, on a quiz, on end of course exams, on the STAR test. Okay, if y is 15 when x is 3, then what is y when x is 12? Okay, when you literally read this, you're thinking, I already know what x and y are. Why are you asking me for a different x and y? They want you to find the constant proportionality first, and then find the new y. Okay, this is the same exact thing. It's saying, if y is 15 when x is negative 6, then what is y when x is 4? This is the same exact thing. Okay, so step 1, you find k with the given x and y. Find k with your given x and y. So you're given that x is negative 6, y is 15. You use the direct variation equation, y equals kx. Y is 15, x is negative 6. Pardon me, that should be a k. You solve for k. Divide both sides by negative 6. K is, and let's simplify. Let's divide everything by 3. This is negative 5 halves. So now we know the constant proportionality. It's negative 5 halves. Okay, so now we have y equals negative 5 halves x. Okay, now we need to know what y is when x is 4. So we literally plug in 4 for x and solve for y. Y is negative 5 halves times 4. So back in the first video, I mentioned how you can change an integer to fraction form by just adding on a denominator of 1. And that's what I'm going to do here. So I do numerator times numerator. 5 times 4 is 20. 20 divided by 2 is 10. I include the negative. Y is negative 10. So that's how you would go about solving a problem like this. So first, find k with the given x and y. Go ahead and write the direct variation equation. So y equals kx. Okay, so now that you find k, you're going to put k here because we know what this is. So we know this now. Okay, so we find k. We plug that into the direct variation formula. So y equals kx. We know what k is. And then we're going to use that to solve for the missing variable. Which could be either x or y. So in our case, it was y, but it could very well have been x. So B here, they want you to find x. But this is a much simpler direct variation problem, and you can use mental math to solve it. So when x is 1, y is 7. When x is something, y is 14. How did I get from 7 to 14? What did I multiply by? Hopefully you said 2. So you'll multiply this by 2, and x is 2. This one you can do mental math on, this one you cannot. Okay, that is where you follow these steps. Find k, we'll go ahead and write the direct variation equation, and then solve for the missing variable, either x or y. You can pause here, finish whatever notes you need to, otherwise I'm moving on. Okay, to finish up, you're going to do 8 and 9 by yourself. Then you have a worksheet on direct variation practice. There are 7 problems total. Okay, so let's do some math. 7 for direct variation. Going back to the third video with the writing linear functions using a calculator, there are 10 problems. To the quiz, which is just more practice and a review, there are 15 problems. And then going back to the very first video, there are 17 problems. Okay, so slope-intercept form, which was video 1, there are 17 problems. The quick video I did on horizontal and vertical lines, that kind of goes along with the quiz, and there are 15 problems. Then the notes with linear functions with the calculator, there are 10 problems with that worksheet. And then for day 8, which is direct variation, I did most of the note problems. I want you to do 8 and 9, and then there's an additional 7. So altogether, 10 plus 7 is 17, 17 plus 17 is 34, 34 plus 15 is 49. So you have to do a total of 49 practice problems, which means come Friday, when I check your math notebook, there should be 49 practice problems, solved or attempted. If you did the notes problems as well as the practice problems, good for you. I'm quite proud of you. I'm glad you did it. Because the more practice you get, the better you'll be. If anything was confusing, if anything was unclear, email me. Post a comment in Google Classroom. Post a comment on my YouTube videos. Some of these videos will not be on YouTube. They will be via Google Classroom or Google Drive. So you'll have to post the questions in Google Classroom or just email me. You also have your classmates. You have your peers. They can help you with this. Okay? There's some people in this class who know what's going on. Ask them. Okay? When I get back Friday, we will reconvene. We will discuss. I will answer any questions you have. But you have all the tools now so you can prepare for your test, which, by the way, I did say in the email it would be next Thursday. It's going to be next Friday because Fall Festival is next Tuesday. We're going to be gone. I will not see you. But I will see you Thursday and Friday back to back. So we will review Friday. We will review Thursday. You will test Friday. Okay? And I want you guys to get 100 on it so you can help your team get 500 points added to your score. What you cannot do, because you will hurt your team, is to not bother doing any of the problems, to not write down any notes. Okay? This math notebook check is a double daily grade, so that is 2 sets of 50 points. So really it's 100 points, and you could get 100 points per person added to your score. If you decide not to do it, that's 2 zeros in the grade book. That's 1,000 points taken away from your score. And it's an additional 200 points off for not doing your work. I am being quite serious, guys. You are here to get better. I am here to help you get better. I cannot help you if I don't know what you need help with. So as you are going through these videos, as you are doing these problems, write down questions so that when I come back Friday, I can answer them all, or the majority of them all. Okay? I will post my tutorial schedule for next week as well, and you will have all week to get help. Please, 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 please be active. And a last fun note, I hope to see you all Thursday roller skating because I will be there and I will be having a lot of fun skating around and being silly. So These are all the videos. You have everything you need. You should be able to complete all the practice problems. You should be able to do the test review. And I expect to see questions. I expect to see emails. And remember, those are points towards your team's score. So make the most of it. Okay, good luck, guys. Sorry I'm not going to be here. I'll miss y'all, but I'll see you on Friday.